All right, I'm going to help you with some of the homework problems in 6.3. This has to do with vectors. So let me just start off with number 13. Okay, in number 13, you're given an actual vector picture. And that picture shows a vector that basically has a terminating point at 1 comma 3. Okay, so here's the vector that you were given. Okay, you were told that its terminating point is 1 comma 3. And the instruction in the problem was to find the component form and magnitude. So we want component form, okay, and we want magnitude. Okay. So component form again is a vector that originates at the origin, which this one does, and what we reflect in the component form in these types of brackets is effectively the terminating point. So in this case, the vector terminates at 1 comma 3. This is our component form of the vector. In terms of the magnitude of this vector, let's just call this vector v. The magnitude of v, we use the distance formula. Now because it originates at the origin, we don't need to do x2 minus x1 because x1 is 0. We don't need to do y2 minus y1 because y1 is 0. Effectively, all you need to do is take 1 squared plus 3 squared, okay, which is the square root of 10, and that would be the magnitude of this vector. Okay, so that's how you would do number 13. Let me go ahead and do number 23. In number 23, you're given an initial point of negative 1 comma 5, and you're given a terminal point for this vector at 15 comma 12. And again, we need to put this into component form and find the magnitude. Well, in this case, again, this is our initial point. This is our terminating point. We're not at the origin. So in terms of putting this in component form, we need to find the difference, if you would, on the what we'll call the x values and the difference of what we would call the y values. So we're going to take terminating point minus initial point, 15 minus negative 1, and 12 minus 5. Okay, and so our component form for this vector is going to be 16 comma 7. All right, and in order to find the magnitude of this vector, we're going to follow the same strategy we did before. We're going to take the square root of 16 squared plus 7 squared, and we're going to get the square root of 305. So in the case where the initial point is at 0, 0, okay, the component form is simply the terminating point. In the case where the initial point is not at 0, 0, we can find the component form by subtracting the terminating point x minus the initial point x, and that would be one value, and then the terminating point y minus the initial point y, and that's going to be your other value, at which point we can find this magnitude of this vector by following this modified version of our distance formula. Let me go ahead and do number 31 for you. In number 31, you're given a vector u in component form 2 comma 1, and you're given a vector v in component form at 1 comma 3. Now in this problem they're asking you to find u plus v, u minus v, and 2u minus 3v and do a sketch. I'll go ahead and do part C, which is 2u minus 3v. Okay, so the first thing I do is I'll find 2u. So if u is 2 comma 1, 2u is going to be 4, okay, comma, because 2 times 2 is 4, and comma 2. Okay, so that's going to be our component vector for u. And in the case of v, we have 3v, okay, which is going to be 3, 9. Okay, so those are our component vector points. And what they want us to do here is to find u plus v, or 2u plus 3v. So for 2u plus 3v, I'll go ahead, actually 2u minus 3v. For 2u minus 3v, I'll go ahead and do the subtraction. Okay, 2u minus 3v, 4 minus 3, which is 1, and 2 minus 9, which is negative 7. So 2u minus 3v in component form is going to be that vector. Now they want you to sketch it. So in order to do the sketch, we'll go ahead. You'll do this on graph paper. We'll plot each of these individual components, and then we'll plot the result. So in terms of plotting 2u is at 4, 2. So here is our 2u vector. And 3v is at 3, comma 9, but we're going to be subtracting. So we're going to plot negative 3v. Negative 3v is negative 3, comma negative 9. Okay, so negative 3, negative 9 is somewhere down here. Okay, that'll be negative 3v. And when we plot 2u minus 3v, we're going to plot at 1, negative 7. Terrible line, but that's basically 2u minus 3v. And if you did it right, it should roughly make a parallelogram, which in this case it does. So here's your answer algebraically for 2u minus 3v, and here's your answer graphically. Let me go ahead and do number 43 for you. In number 43, you are given a vector v equals to I plus j. And what you're asked to do is find the unit vector in the direction of this vector. Okay, so in order to find the unit vector, in terms of, which one are we doing, 43, in terms of finding the unit vector, okay, I plus j in component form is 1, comma 1. The magnitude of v is basically the square root of 1 squared plus 1 squared, which is the square root of 2. So our unit vector in this direction will be 1 over root 2i and 1 over root 2j. And we can address the radical within the denominator. So we're root 2 over 2i and plus root 2 over 2j, and that would be your answer. If you actually look for the magnitude of this, the magnitude of this will be 1. So this is the vector in ij form that's in the same direction as our original vector. And the way we found it was, we took the original vector and divided it by its magnitude. Alright, let me go ahead and do for you one last problem. Let me do number 51 for you. In number 51, you're given the magnitude of a vector equals 9. Okay, and you're given the direction vector as u equals 3, comma 3. And you're asked to find the vector v with the given magnitude in the same direction. So it's a little bit similar to this, but not entirely. So, and again, we're doing, this is number 51. It's not 3, comma 3, it's 2, comma 5. Okay, 2, comma 5. So what we're going to do is the magnitude being 9. We remember in class we'll take that 9 and we'll multiply it by the component form u, and we'll divide that by the magnitude of u. 2 squared is 4 and 5 squared is 25. 25 plus 4 is 29. This is the square root of 29. And so the vector that we're looking for then will be 9 times 2, which is 18 over root 29. And they asked for the answer in component form here, I think. So we'll leave it in component form. 18 over root 29. And 9 times 5 is 45 over root 29. We can get rid of the radical in the denominator by doing this. And this would be a vector. Okay, this would be a vector that's in the same direction as u, but has a magnitude of 9. If you were to go ahead and find the magnitude of this component form vector, it would be 9. Hope that helps. Good luck.